everyone. Welcome to Cellular Healing TV. I'm Ashley Smith. Did you know there are 3 animals that are very cancer resistant? Elephants, ants, and the naked mole rat. How can humans gain the same advantage as these remarkable creatures? Our guest today has done amazing research on the topic, and he's here to discuss how our bodies can actually build up defenses to repair and even stop mutated cells from replicating. Our guest's name is Spencer Feldman, and he's been formulating and manufacturing detoxification products for 2 decades. Awarded 2 U.S. patents, his suppository versions of chelation therapy, liver gallbladder flushes, and coffee enemas have helped tens of thousands of people improve their health. This is one fascinating episode. So let's get started and welcome Dr. Pompa and Spencer Feldman to the show. This is Cellular Healing TV.
This is a great show because you have a great interest like I do. We both do detox very similar. We believe it has to happen at the cell. Myself and my doctors, we have utilized many of the products that you've created because one of the challenges that we face with detox is people with bad guts. So you've created some suppositories that we absolutely love. And you know how I actually found your company was because some people, the darn coffee enemas, which help detox so much, right? It opens up that liver pathway and gets the bile moving, which gets toxic. Well, you found a simpler way. The product's Zetoplex, and man, we fell in love with that product. It's basically, folks, a coffee enema in a suppository, and I use them all the time. Matter of fact, I turned my friend Ben Greenfield onto them because when he travels, he wants to do his coffee enemas, and he absolutely loves your product as well. But it goes beyond just Zetoplex, so we're going to dive into that. But I want to have some discussions here, about cancer and about how toxins are relating to this big epidemic, because that's big into your heart. And then we'll kind of pull some of these really unique products that you've developed into this conversation. So we'll start there, but start with your story, man. I always start there because always somebody that dives in as deep as you do, we all have a story. So how did you get into this?
Well, I wanted to be an emergency room physician, but my hands when I was in college were shaking so bad that I couldn't drink soup. And so I went to the doctor and I said, what's up with my hands? And he said, well, here's a drug. And I'm like, all right, but what's up with my hands? Why is this happening? And he didn't want to give me the time to answer, or maybe he didn't have an answer.
Yeah.
I traced it back probably to, there was, I think, a measles outbreak, not an outbreak. One person perhaps got measles in my college, so they mass vaccinated everybody. And I believe my hand shaking started right afterwards in retrospect. So I probably got a little bit of a vaccinosis reaction. And so I went to acupuncture school. That wasn't for me. I like it, but I don't like needles. And then I just started, I think it was around the year 2000 that the internet became really available. And so you get onto PubMed and you could read published journals in 12 different languages from around the world on any topic you wanted. And I really fell in love with alternative medicine. And I ended up, going from making it a hobby to get my own health better to making a career as a formulator.
Yeah.
Great.
Yeah, no. And like I said, we really love the products. It works so amazing right along with my cellular detox, same principles. Let's talk about cancer. Let's jump in. Today, I'm constantly lecturing on the fact that chemicals, neurotoxins are the biggest driver of why we're seeing an explosion of cancers, even kids. Since the 1950s, it's estimated that 67% increase in childhood cancers. When you look at the research, environmental toxins, neurotoxins are the driving factor. And with some of this new research around glyphosate being sprayed on all our foods, all right, what's your take on it?
Well, I came to some of the same conclusions. I was curious, have we always had cancer? And they do find cancer or traces of cancer in the bones of prehistoric people. But when I came across some studies, I think they were out of Sweden, and they showed that cancer really started skyrocketing right about the 1950s.
Yeah.
So I started looking like, well, what was happening in the 50s? And that's when we started doing atmospheric nuclear testing. And if you look at the number of tests that happened over time, and you look at the global worldwide production of plastics, chemicals, pesticides, and you lay them over the cancer graph, these are identical graphs.
Yes.
You know, is it causing it? Is it causality? Is it correlation? I don't know. I think it's a pretty good smoking gun that the increase in the chemical toxic load that we've been exposed to is a prime driver for cancer tissue.
Yeah. Yeah. So, people are saying, okay, great. But I mean, kind of give them at least a brief understanding, just, not too much science, but a brief understanding of how it happens. I mean, we're very educated here on heavy metals, a toxin like a heavy metal, which today there's science showing that glyphosate, which we're spraying on all our food, actually allows these heavy metals to go deeper into our brain, into our cells, which we know is driving cancer even more. But give them a brief explanation of this, because I really I'm building the value here on why it's so important to detox and do it right.
All right. So cancer, from what we think it is now, is a dysfunction of the progenitor cells, which is halfway between a stem cell and normal tissue.
Mm-hmm.
Stem cells can differentiate and become anything. Progenitor cells have already differentiated a little bit, but they can still kind of change their state. They can still change to become other things. And then stable cells, they do the one thing they're meant to do. So it's this intermediary cell. It's a progenitor cell that we believe is where cancers are coming from. And there are the main theory behind cancer is it's caused by mutation of the DNA. And it's estimated 6 or 7 mutations is what it takes for a cell to become cancerous. So, but there is another cause, I believe, for cancer. I would call it the adaptation kind of cancer. And I'll explain the differences between the two of these. A mutating cancer would be someone who's exposed to some kind of toxic chemical. It damages the DNA enough. Yeah. It escapes surveillance of the body, starts replicating, and there's cancer. An adaptive cancer, I would say, is kind of negative epigenetics. In other words, some slow toxin, and I think it's mostly metals in this case, gets into the system and changes the environment the cell is in. Rather than the cell genetically being mutated, the cell itself adapts to the new environment, and that adaptation is cancer. And I think it's important to understand both ways in which cancer form: an immediate toxic insult from chemicals and a more gradual long-term insult from metals, for us to really be able to get a handle on cancer. And of course, what we're going to need to do is detox the chemicals and detox the metals. And I suppose the first thing we could talk about is, well, okay, how would we detoxify the chemicals?
Yeah, no, absolutely. And you and I both agree that real detox starts at the cell, right? I mean, our cells have natural abilities to get rid of toxins. The problem is they get overwhelmed. Cell membranes get inflamed, right? Pathways, glutathione, I mean, all of it gets overwhelmed. And now the cell isn't able to get rid of toxins, even the toxins that it makes when it makes normal energy, right? The example I love to get, it's like burning a fire. If you don't have a chimney, you're going to die. Well, that's our cells, they become chimneyless. So, I mean, and then the second challenge is what's getting it out of the body, right? I mean, you have to deal with both of those challenges. So talk a little bit about that.
Okay, so let's work with chemicals, because metals is a different detox pathway, and we can get to that in a minute. The chemical detox pathway, there's 3 phases of it. As you know, there's phase 1, phase 2, and phase 3. Phase 1 is where you attach an oxygen out of a molecule to a toxin and make it more reactive.
Yeah.
Phase 2 is when you attach something else to that oxygen, glutathione, but there's others, and we could talk about those. And then now it's able to be moved around. And then phase 3 is where it comes out: urine, sweat, out the stool. And when you see people who are having detox reactions, it's my belief that the protocol they didn't get all 3 of those phases.
That's right.
By the class, because what happens is phase 1 will temporarily make a toxin more toxic, more reactive. So if you have someone who gets a phase 1 detoxifier, and they don't have phase 2 capacity, they've actually just, caused a worse problem. They've made their toxins more reactive, but more capable of causing problems, but not necessarily more capable of leaving the body.
That's right.
So as you were mentioning, coffee enemas, this is the classic phase 1 detoxifier. Were we living a more natural lifestyle, we would be eating a lot of bitter foods. And bitter foods in nature, that's what stimulates the P450 enzymes, phase 1 detoxifiers. But if you go to the grocery store, there's hardly anything bitter left. It's been bred out of our agriculture. So we get very little bitters to stimulate phase 1. And so the other issue is the toxins we are exposed to, I call them stealth toxins. They're not bitter. Aspartame can actually be sweet. And so we are getting less bitter stimulation in our diet to upregulate our natural phase 1. And the toxins we're exposed to, because they're not bitter, they're not what our genetics are used to seeing, are not triggering our body to get rid of them. They're stealth. So phase 1 would be, the classic would be the coffee enema, or in this case, suppository, how I like to do it. Phase 2 is the conjugation, and that would be things like glutathione, sulfation, so sulfur, methylation, acetylation, which is B5, basically, it's how we get rid of antibiotics, and glucuronidation. And when the goal behind the detox for me, from my perspective, is we stimulate phase 1. At the same time, we provide the raw materials for phase 2, because if someone doesn't have enough of the phase 2 detoxifiers in their body, and you give them a phase 1 stimulant, again, the body will start mobilizing toxins incompletely, and they're going to feel terrible. So we give them at the same time the conjunctive agents.
Yeah.
Then you have to make sure the last part is the gallbladder full of sludge, or is it a straight shot out for the fat soluble toxins? Are the kidneys operating properly? Are the main phase 3 exits open? And so I feel like that's a really great way to get a handle on the chemical toxins. You phase 1 with coffee rectally, phase 2 with the conjugators, and phase 3 with something that would flush out the kidneys and the gallbladder.
We built a product some years ago, and it's a G cell, and it kind of combines that phase 1 and phase 2 for that reason, right? Because you both, man. So when you don't, and of course we love, doing coffee enemas, and for that reason, coffee enemas too. I mean, you can consider it part of phase 3 too, because when you push that bile out, you just empty that gallbladder, which when that's blocked up with hepatic biliary sludge, it's magic. And then one of the tricks that we do, even with the Xenoplex, your coffee enema and a suppository, we take a product called Bind first, like 30 minutes, 45 minutes ahead of it. It has 4 different binders that just sit in the gut as a catcher's mitt. And we dump into that and pull it out, which represents, in that case, phase 3. But you're right. I mean, by stimulating that oxidative process in phase 1, you get kind of both with that. So. Yeah, I mean, that's it. And people have to understand that a lot of that, again, it starts at the cellular level. You have to, obviously, glutathione at the cell, the liver, all of it plays a very critical role, methylation as well. So,
taking fiber is a fantastic idea, and I don't recommend it as often as I should. In the same way that the Xenoplex was a modern recreation of the coffee enema, the Glytamins was my idea for a modern recreation of the liver gallbladder flush.
Yeah, I was just going to talk about Glytamins because we use it as well. It helps push out that biocomplex.
Mm-hmm. I've started looking at people with ultrasound, and then you look at someone's carotid artery, and we could talk about that in another talk. How many people are walking around with a enormous plaque in their arteries? But you can also see all sorts of junk hanging out in people's gallbladders. There was one woman who, I think she was in her 80s. This is an interesting story. And she calls me up to thank me because her headaches are gone. And I said, oh, that's very nice. She'd taken some vitamins. And she goes, no, thanks. The headache's gone. I'm like, well, ma'am, how long have you had your headache? And she said, 65 years, something absurd. She had had, how do I say this? Is it possible that she had a gallstone for 65 years and that was what was causing all of her pain? So, being able to flush out the gallbladder, I think it's a great thing. And especially because some people have, I believe mistakenly, gone on very low fat diets. And what that does is that can be a setup for gallstones.
Yes. Yeah, no doubt. And the glytamins makes it easier, because really, doing those gallbladder flushes, they're worse than coffee enemas. We'll just put it that way. I prefer to take the glytamins myself. Yeah, I mean, both of those products really assist this process big time. All right, well, let's jump into a new product that really excited me that I can't wait to carry. It's brand new. We're the first to hear about it right here. And this is more focused on a specific, specifically cancer. So talk about the new product we're going to be launching it and how it works and why it's so different.
Do you think we could talk about metals first?
Yeah, absolutely.
Okay,
yeah.
Great. So the other half of the equation for toxicity, I think, is metals. And I think that we have to treat metals differently than we treat the chemicals because they cause different problems and they have to be addressed in slightly different situations.
Well, and I agree from a standpoint, you need different chelators and binders because they're a bitch to get out. The glutathione doesn't hold on and pull them all the way out.
So let me tell you what I've kind of my thoughts on metals and in this case, cancer. So the cell membrane, which you and I are so mindful of helping for our clients, has its job is to let certain things in and out, control the intracellular environment. And it wants to have a lot of potassium on the inside, and it wants to keep the sodium on the outside and let calcium in only under certain conditions. And the way it does this is with three types of machines, you might call them. There are pumps, transporters, and channels. The pumps push things in and out. It takes energy, it takes ATP to do it.
Right.
The transporters, they don't take energy. What they do is they're like a revolving door. So let's say here's the membrane, and this is something that they want to get in, and this is something that they want to get out. They might switch them, or that would be an anti-porter in opposite directions. And a symporter would be they want to get both of these things in. This is going to pull in this one, and they both go through. And then the last one is channels, which is like just a hole that things shoot through really quickly. And so these three things, the pumps, the transporters, and the channels, are what allow a cell to maintain its housekeeping, to bring in and out what it wants. Now, here's what happens. Here's the problem. Toxic metals can, through molecular mimicry, get stuck in these transporters. As an example, mercury and sodium both are 1.02 angstroms-ish, right? Atoms have a bit of wiggle to them. They're not like billiard balls, but they both are 1.02 angstrom in size, which means that the all-important sodium channel or sodium pump, the mercury can get in there. Now, in order for a pump, a channel, or a transporter to work, and mostly, a lot of what it's doing is moving ions, moving metals. So let's say it wants to bring in some potassium from outside the cell, inside the cell. It will grab onto the potassium and then pull it in and let it go. The let it go part's important. If it grabs on too tight, it can't let it go. And now you've got something stuck on that transporter, that pump. It doesn't work.
Yeah.
This is what happens with the metals. Mercury, or divalent mercury in any case, has a +2 charge and almost identical in size to sodium. So when the mercury gets into a sodium channel or a pump, the same size, charge is different. It can get stuck there.
Yeah.
And now that particular pump can't work. It can't move things the way it wants. Another example is barium and potassium. I think barium is 1.35 angstroms, potassium is 1.38. They're very close. And again, barium with a +2 charge, potassium +1. The barium gets into the transporter for potassium, and it grabs on, and it just jams up there. It doesn't let go. And basically, it's like, so think of metals as membrane glue.
Mm-hmm.
They stick up, they sludge up the machinery, the pumps, the transporters, the aquaporins, the channels that are required for a cell to function properly. Now, here's something interesting I read in a study. It said that all known carcinogens decrease intracellular potassium and raise intracellular sodium. Well, what they're really saying is all known carcinogens damage membrane, pumps, transport, and channels, because that's what's keeping those things at the right levels. And also you find a lot of calcium inside the cells of cancer cells because the pumps can't get it out, and calcium is the on switch for a cell, and a cancer cell is constantly on. Mm-hmm. So what I think metals do is they get into the membranes by looking like the ions that the transporters and pumps and channels want to move, and sit there and jam things up. And the cell is unable to regulate itself. And then what happens is over enough time, the cell epigenetically, it changes. It says, well, I can't function in this environment with this high calcium, high sodium, low potassium. How do I stay alive? And cancer is that adaptation.
Yeah, no, I mean, it makes sense. I mean, there's many theories, obviously, right? And this is another theory, but I believe it's plausible because I know it really is the membrane. Here's the other factor of that, and I draw that out, how the metals attach to these membranes. The problem is the membrane is the critical component of changing the epigenetics, right? Mm-hmm. So literally, you don't change a genome, you don't turn on gene, a good one on and a bad one off unless you fix the membrane, and vice versa. When the membrane's fouled up, now all the bad stuff starts turning on in the epigenetics. So, yeah, this is it's a multifaceted problem. I mean, just even the cellular energy component, because now all of what you just described is happening in the mitochondrial membrane as well, right? So now you're not making ATP. Now you're driving inflammation pathways, feeding back into positive feedback loops. Oh my gosh! I mean, there's a zillion ways that heavy metals drive cancer and other unexplainable illnesses, including autoimmune. So, I mean, it is all a cellular issue. So, when we were, this cytodetox, it has the small enough particles to get into these membranes and grab onto something strong enough to pull it out. Otherwise, if you don't free the membrane, you're not detoxing. So I love to say everyone's doing all these detox protocols, that make them poop more. But ultimately, what you just described is the big problem. This is the area that nobody's really paying attention to in the detox world.
Yes. So, one way that you can check the health of the membrane would be with phase angle, right? And, we typically go from a phase angle of 8 when we're young, peaks when we're, say, 24, and then it drops down to 5.5 when we're 70 or 80. But you'll see lower phase angles in people that are precancerous, and then of course it's the lower the phase angle, the worse the prognosis or short survival time. So I think testing phase angle is fantastic because what you're testing is the voltage of the cell, and that is right, and that's being driven by the pumps, which is creating the gradients. As an example, cancer cells usually have a voltage of between -5 to -38. I think the prostate's a little bit lower, but that's the rule. And then normal cells are between -38 and -93, with the exception of, I think, fibroblasts and some other things. So as a general rule, 38 is the cutoff. If a cell goes below 38 millivolts, that's cancer, and if it goes above, it's not. That's a generalization. But what we know from studying is that you can take a cancer cell and stop it by raising its voltage. And you can take a normal cell and make it cancerous by lowering its voltage.
Yeah.
So it's a huge thing. And in terms of the idea of whether or not metals are associated with cancer, there was a study, it was an 18-year study following up in Switzerland, where they followed up people that had done 20 chelation treatments, so clearing out metals, and it was a 90% decrease in cancer deaths. So yeah, the metals are enormous problem, but they happen slowly enough that they're not, it's very stealth, right? It's not, if someone is at a work site and gets a solvent exposure, they're sick right then and there. Someone gets some fillings in their mouth or, has some metal exposure,
Years.
Slowly drains them out, because it's this other thing. It's the voltage dropping, it's the cells, it's a membrane going down. So I guess what I would say is, being able to get rid of metals is just as important as chemicals. Metals are more like the time bomb. And the perspective I have is very close to yours. We both come to a lot of the same conclusions in terms of getting rid of things. And the way I see it is the kind of things that can go inside the cells, glutathione, they can pull out metals and such, but they don't make an incredibly strong bond.
Exactly.
Right. And it may be necessary for them not to make a strong bond, because otherwise they might get stuck in the channels. Right. So they can go in, they can grab onto the metals that can come out. But once they're outside, they can, under certain circumstances, redeposit, let go of the metal, and now the metal just finds its way to another bit of tissue. So the perspective I have is to mate or to join two different kinds of metal remover agents, at least. One, something like glutathione and the products that you carry to go inside the cell.
Yeah.
And then once it goes in and comes out the membrane, EDTA or something with a really strong charge.
That's right.
To pull the metal off the glutathione, take it out the body, that functionally recycles the glutathione. It can then go back in the cell and get more. And that kind of relay system, I think, is a fantastic way to go and get metals out of the tissue.
I couldn't agree more, and just taking something like EDTA, DMSA, or one of these really good chelators by itself, there's more to it than that. But taking them correctly is part of what we just described. It's key, because you need those type of chelators and binders to actually move something like heavy metals out of the body. And then again, where we started the conversation, keeping it moving through the liver and the bile and out through the gut, critical component in phase 3. Yeah, we see the same. Most people, I'm gonna be honest. When I look at the functional medicine world, most people are doing detox incorrectly, and I'd have to say even the top names in this industry. And I'm not going to point fingers, but it amazes me that they violate the very principle that you and I just described. We've never had this conversation. Obviously, we're reading literature and going, okay, well, this makes sense. And now, I have, an incredible advantage of doing this over many, many years, training doctors, figure out what works, what doesn't, but what you described is what works. And I believe it's backed by the science. Well, I do want to talk, I'm very excited about your cancer product. So I tried to pull you into that earlier, but I'm glad we had the heavy metal discussion. So, but, talk about this new product that we're going to be carrying. That I think is going to be healthy for everybody, but talk about the product.
Okay, so caveat, I'm not calling it a cancer product.
Yeah, okay. Well, I didn't want to mispronounce it, so that's why. Because first of all, I went Mito and Pinol, and so you said, oh, it's Mitopenol. So I was like, okay, I'm going to mispronounce it. I'm dyslexic.
Okay, so, let's say, we have taken someone who, and we pulled out as many metals as we can, and they're still staying with it, and they've pulled out the chemicals, they're staying with it. But remember, it's the 6 or 7 mutations before a cell becomes cancerous.
Right.
And, there are numbers thrown around that the average person creates and destroys 1,000 or so, or 10,000 cancer cells a day with a good immune system. Those are the cells, that have got 6 or 7 or more mutations. But what about all the cells that have 4 and 5 mutations? They're not cancer, but boy, are they close, right? So when we detox someone and they stay on detox, we've gotten rid of, as best we can, the causes, the drivers for the two types of cancers that we've discussed. But we haven't done anything for all those time bombs sitting in their body waiting to go off. All of those cells that have been exposed to environments that are inappropriate because the pumps and transporters are gotten jammed up, and that have mutated because of the chemicals. So my perspective is we also need to do something to deal with the cells that are problematic, right? And so what I did is I looked into the animal world. I said, okay, you know, millions of species, a lot of them get cancer, most of them do, even plants. Have any other animals, raise your hand. If you're an animal that's figured out cancer, please raise your hand. I'd like to talk to you, right? 3 animals raised their hand. Okay, we got ants, we've got elephants, and naked mole rats. And so let me tell you about these 3 because they're kind of the basis of the mitopenal product. Elephants very rarely get cancer. And the idea is that it's because they overexpress a gene called TP53. They have 20 times more TP53 genes than we do. And it's a very important gene in cancer protection. What it does is if a cell is getting a little wonky, that gene will cause that cell to stop cell arrest, so it doesn't grow anymore. Then what it does is it will fix it if it can and destroy it if it can't. Very important gene for protecting against cancer.
Yeah.
And 50% of all cancers are associated with a mutation of the TP53 gene in humans. Now, we only have 1 copy of this gene. So if this copy goes bad, we don't have 19 more like the elephant to back us up. What we can do is we can simulate the TP53 gene. And I think the best thing for that is ellagic acid. Ellagic acid does the same things as the TP53 gene. I believe it causes cell arrest. We know it can repair genes. And the reason we know this is because there are 95% less DNA adducts after someone has been taking ellagic acid. A DNA adduct is a bit of genetic code that's gotten damaged and getting out of the system. So if you are decreasing the amount of DNA adducts, what you're functionally doing is you've shown that your DNA is in a healthier state. It's got less things being removed from it. And again, ellagic acid has shown a 95% decrease in DNA adducts. And then finally, ellagic acid is fantastic for apoptosis, which is getting cells to commit suicide. So from what I can see, ellagic acid is a near complete replacement for a TP53 gene. I'll be taking ellagic acid, you know, it's the last day I'm alive. It's an amazing ingredient.
Yeah. Yeah, no doubt. You know, it does something that happens in fasting. It actually stimulates autophagy with the body just simply. It's, you know, apoptosis is a part of autophagy, but it literally, it will stimulate that cell-eating process, getting rid of the bad cells. The innate intelligence knows, right? It just helps that pathway, which is incredible. We're excited, you know, to carry that product as well. I think it's going to be a fantastic product. You know, I do want you to say a word about your process. You know, you've been doing suppositories for 20 years, and there's a lot of other people who have come along now and are doing suppositories. So how is your process different? Why is it better? I chose your product, but you tell the story.
Well, let me just finish the ants and the naked mole rats, and then I'll answer that question.
Oh, okay, I thought you were done with that.
Okay. So
I figured the ants. I figured the naked mole rats and the ants.
No, they've got their own thing.
More.
Yeah. So if 50% of cancer is associated with a TP53 gene, and 50% of us die of cancer, that means in our lives, a quarter of us are going to need some help with this gene. But that's the elephant world. Right? So that's how we can be more like elephants. How can we be more like ants? Ants very rarely get cancer, and they have virtually no immune system. But what they do have is a spectacular genetic repair system. So they basically said, we'll repair ourselves so fast, it doesn't matter what you throw at us. And there's an ingredient, it was discovered by Hans Niebuhr, a great physician from Europe, called iridoidal, if I'm pronouncing it right, and I might not be. And basically, it's an ant extract. Iridoidal is an aldehyde, and I would love to see some chemical pharmaceutical house make this stuff by the kilo. As far as I know, they don't. And until then, if we want to have this kind of ant defense mechanism, we're going to have to eat concentrated ant extract. Fortunately, it doesn't taste very bad. Third thing, the naked mole rat. The naked mole rat, as opposed to the elephant, the naked mole rat is actually immune to cancer. You cannot create cancer in a naked mole rat in a laboratory condition, or at least that's what I've heard. It also lives 7 times longer than its most similar sized, say, house rat or mouse. So it lives longer by 7-fold and is basically immune to cancer. So I wanted to understand why this was. And what the naked mole rat does is it creates a different kind of hyaluronic acid than we do. I think it's 5 times bigger. And so that's the connective tissue that we're built in. And I believe what happens is the hyaluronic acid is the first thing that a cancer has to get through to become invasive. Now, the naked mole rat, number one, makes an enormous amount of hyaluronic acid of a slightly different kind than we do. And it has very downregulated hyaluronic acid enzymes, meaning the enzymes that would break hyaluronic acid down, it doesn't really make it. Right. So if we want to be more like the naked mole rat, then it would be increasing our hyaluronic acid intake, but at the same time, suppressing our own endogenous enzyme production for that enzyme which breaks down hyaluronic acid. So the mitopanol product, it was based around these 3 animals, the elephant, the ant, and the naked mole rat.
I would argue it'd be good for your joints as well, potentially, because hyaluronic acid plays such a key role in your skin as well.
Yeah, sure.
Yeah.
So that was the intention. What I said is, okay, what are the ways in which people typically die is heart attack and stroke, and that's the same thing, just in a different location.
True.
And then cancer. And so I said, okay, what animals, if any, have dealt with cancer? And so the whole cancer angle, from my perspective, is detoxify chemicals and metals, and then take a lesson from these 3 animals that have such amazing cancer defense systems.
It's beautiful, Spencer. And, just we're going to be carrying you mentioned heart disease and strokes as the #1 killer. We're going to be carrying that product. We don't have time to talk about it today, but we'll have you back for sure. But just give them the name of that product so they'll see it here on at least the Revelation Health will be carrying it.
Sure. That one is Rubiplex. And basically, I'll tell you a little bit about it just as a teaser. What happens is when the blood starts to get too coagulated, it starts to erode the arterial wall. And plaque is basically a failed healing process of an arterial insult. More on that one later. Yeah. And that one is called Rubiplex.
Yeah.
But to answer your earlier question, what got me into suppositories and how are we different? There's a lot of ways into the body. Powders, capsules, injections, transdermals, and intranasal, and suppository. And the reason I like suppository is there's a couple of things. One is some of the best ingredients don't survive digestion or don't survive very well. So we bypass the digestive tract. It's not mixing up with a bunch of foods and liquids and getting worked on by acids and enzymes. It's in the rectum, and it goes, suppositories go right through into the portal vein, right into circulation. So we get a much higher absorption. So take something like serrapeptase, for instance, or EDTA. Perhaps these are 5% absorbed orally. You can get a lot more into the body as a suppository. Another thing about it is location. It's right there against the prostate and the portal veins of the liver. So if you want to work on those two organs, that's a great way in. Another thing I like about suppositories is they're sealed again. They're sealed from light and from oxygen when they are made, so they've got a decent shelf life.
Yeah.
So, but what makes us different? Well, we are the longest running suppository manufacturer in the U.S. that makes things for the alternative health community. We've been doing it for 20 years. We make everything ourselves. In terms of ingredients, we don't put in a lot of the things that other people do to make their equipment run better.
Yeah.
What's not really spoken about is all the fillers and lubricants and binding agents and chemicals that are used in the manufacture of supplements. As an example, a lot of suppository manufacturers will use methocel, which is a synthetic base, which is mildly toxic. So we use cocoa butter. It's more difficult to use cocoa butter. Ask anyone who makes chocolate, who's a chocolatier, they'll tell you cocoa butter is a little challenging to work with, but it's clean. So we make everything ourselves in our own lab. There's nothing that's in it. Everything that's in it's on the ingredients. We don't use anything we don't use solvents to clean equipment. Everything is done in a way that I would want for the things that I'm taking from my family.
Yeah.
And that's what I make for other people.
No, and that's why we use you as well. So, Spencer, thank you. This is a great show. It's really putting the word out. I think it was great explanations on cancer, and your products are great too. So thank you for being part of what we do.
Thank you, Dr. Pompa.
Well, that's it for this week. I hope you enjoyed today's episode. You can read more about Spencer Feldman and his line of supplements in our show notes. We'll be back next week and every Friday at 10 a.m. Eastern. We truly appreciate your support. You can always find us at cellularhealing.tv, and please remember to spread the love by liking, subscribing, giving an iTunes review, or sharing the show with anyone who may benefit from the information heard here. And as always, thanks for listening.